Yes, yes, yes. Oh, woohoo. Okay. Hi, everybody. We are here today for an unboxing of the Microbit and your very first steps to getting started with it. My name is Katie Henry, and I look after partnerships in North America for the Microbit Foundation. I am a licensed K-5 educator, K-9 administrator, and K-12 computer technology integrator. And so the goal of this session is to open the box and get started with your first program. It's a great time to ask questions in the chat. I will multitask and hope to get those all answered for you. Really excited to be here. And with that, I just need to share my screen. Great. So this is the Microbit V2. It is what most of you have, though you may also have a box that looks like this. This is the Microbit V1. They are essentially the same Microbit, except for the V2 has a couple extra features. When you open this box, you will find a little getting started guide. It shows you a few of the sensors that come in the Microbit, including an accelerometer for motion detection, which allows you to shake and tilt to produce different outputs. The microphone on the new Microbit allows you to use clapping or other sounds as an input. It will also record your voice. We are going to connect today via USB, but you can also pair through Bluetooth. And then just a little sample here of the code. You can use MakeCode, Python, Scratch, and through MakeCode, you can toggle to JavaScript with your Microbit. And so it's a very powerful little tool. When you take it out of this electrostatic bag, you see it looks like this. This bag is handy to keep. Most teachers don't save these when they're storing them with their students. They just put no more than 10 microbits in a pencil case for storage. And I say no more than 10, only if they're being moved around from class to class. You don't want to have a lot of microbits just all jostling around together. So 10 to a pencil case seems to be about the right ratio. You can keep them in the bag if you want. The purpose of the bag is to prevent an electrical charge from building up on the board itself and potentially damaging the board. It's not a very common thing that will happen. It's kind of standard protocol to ship any kind of hardware in a bag like this. So you can feel confident recycling these. Okay, so when you take a look at the board itself, you'll notice that everything has been labeled for you. One detail, one question to everyone, is this showing in a mirrored image to you now? Okay, perfect. So it's mirrored for me, so I hope I don't say something or point in a weird place. Okay, so when you look at your Microbit, everything's labeled for you. There's nothing on your Microbit that you can't name, and that's by design to help students really know what it is that they're programming. And so this is the back of the Microbit. So let's start at the front. And in some ways, you can compare your Microbit to something like a cell phone. There is a display here with 25 LEDs. You can program each LED from a brightness of 0 to 9. This LED array also doubles as a light sensor. That means if you have less light or more light, your Microbit can respond. New on the Microbit V2 is this capacitive touch sensor, and it is pressure sensitive. So you can program for a duration of time, a light touch, a long press, again, thinking about the surface of your cell phone screen. 2 buttons, A and B, and these pin connectors here where a lot of folks will use alligator clips. When you're first starting out, you may want to connect, for example, an LED. Well, I'll grab an LED at the end. If we have time at the end, I'll show you how to connect that. It's very simple. Well, why don't I grab it now? I saw in your opening remarks that LEDs were sent out. If you've never used an LED before, it's just a little light. There's a short leg and a long leg, and you want to make sure the short leg is connected to ground. And so the way you would connect an LED to your Microbit is just clip an alligator clip onto one end. You can connect to ground. So that would be one side. You can bend these legs open, and then you could connect the other leg to pin 0, 1, or 2. In this case, I've connected it to pin 0. And so if I'm able to do a proper screen share in a moment, I'll be able to show you how to program this as well. If I can't get to the screen share portion, I'll drop a link in the chat that will take you to my screen, which you could open on your own computer. But let's just keep going for now. So that's what those notches are for. Those notches are designed to hold the alligator clips in place. Now to the fun part. On the back here, you have a speaker. Up in the corner, you see this gold bar. This is your Bluetooth and radio antenna. So your microbits can communicate and transmit data between themselves, between microbit to microbit, or you can pair via Bluetooth to another mobile or another device. Down here at the bottom, you'll see there are loads of sensors on this microbit. You have a compass. We write compass on here, which is unusual because a compass isn't really a sensor. It's an application of a sensor. The real sensor that lives in this chip is called a magnetometer, and it measures magnetic fields. So there's a fun project on the website about using this with a refrigerator magnet on a bedroom door. And anytime the door opens past the microbit, maybe with the refrigerator magnet on it, the microbit can sense the door has been opened because it detects a change in the magnetic field. But you also can use your microbit as a compass. There's another sensor on here called the accelerometer, which is the motion detector. You can measure motion in 3 ways with your microbit: by tilting it left and right, forwards and backwards, and by raising it up or lowering it. So on a roller coaster, on an elevator, on your shoe, you can measure G-forces. Above here, you'll see where the actual processor lives. This is a microcontroller. So that means it's not a computer with an operating system. This processor, this chip here, is executing a single program at a time. This is what we have millions of in our world, possibly, arguably more than actual computers with operating systems. Microcontrollers are in everything. They are in your thermostat, in your microwave, in your washer and dryer. Microcontrollers are all around us, collecting and transmitting data. Scott, about 30 feet. Good question. Scott's question's in the chat. Okay, so we're almost done with all the sensors here. Let me just see what I've missed. At the very top, we have a place to plug in the USB cord. And this little button here will power your microbit on and off. That's a new feature of the V2. You can hold this button for 3 seconds and power down your microbit. You can also use this button to restart a program. If you've made a step counter and you want to reset the step counter back to 0, and you're not near a computer to manually do that in your code, you could press the reset button to start your program over. And then finally, there's a little place to plug in your batteries. So let's go ahead and do that step now. We will open up this other part of the box. There's a nice little battery holder that comes in here. This is perforated, and so you could use this and make a template for more. This is just kind of a nice way to hug around your microbit with the battery pack in place. So this would just fit around here. You can see how this would place for the buttons. So let's get our battery pack out, and you can see how that would go together. Your kit comes with a USB cord. You can power your microbit by plugging it in directly to the computer, but once you separate it from the computer to run your program out in the wild, you will want the batteries to continue to give power. And so the microbit here comes with this batteries you need and 2 AAA batteries. And there we go. So we'll use this connector now to insert in the battery pack here, and the connector. And you just want to plug this in correctly. You see how there's a groove in the center there? you want to make sure the groove, which is on the top, which is right there, slides into place. So I'm just going to put this in just like this. And immediately a program starts to run. This is the startup program. It will execute only once. So if you're using these with students, you don't have to plan this in for every lesson, the first day of class, if you have 6 or 7 preps. So we had some sound, we have a hello message. And next you'll see a smiley face, and it'll tell you exactly what to do. So we do need to calibrate the device by following some directions. If you wanted to skip this step, you could immediately plug this into your computer and download a program, and it would save you the time of going through these setup steps. Okay. So now we've got a message. It's telling us to shake. We are going to calibrate the accelerometer. And so we're going to shake it. Okay, it's happy with that. We should get a message to chase the dot. So maybe I need to shake it just a little bit more. Okay, the music stopped. I shook it until the music stopped. And now it says to tilt. So you see you've got a blinking dot and a solid dot. Watch the solid dot. I'm going to tilt it. See how the dot is moving with the accelerometer? I'm trying to bring the solid dot and the blinking dot together, and I'm going to just chase them. This is a really fun program for your students to actually write to create a little game. And if you can hear, it's making these adorable little squeaky sounds. It's talking to us. Every time I move it, it chirps. Oh, it's so cute. Okay. Very good. So now, let's see what comes up next. Clap. Okay, I'm going to clap, and you can see that the audio detection is listening to the volume. So we need a loud sound. Okay, that was 1, 2, 3, 4, 5, and that was it. Okay, we've got a wow. Microbit's happy. And now we are ready to rock and roll. We've got a heart, and we're ready to write our first program. Okay, so this session is over in 8 minutes, and I want to make sure that everyone is able to see how to do this coding portion, but I seem to not yet have the ability to share my screen. Let me think here. We are now ready to program our microbit. You can do that by coming to microbit.org and selecting Let's Code. And here you can choose your preferred editor. Today I'm going to choose MakeCode. And we're going to call this My First Project. MakeCode is a free software editor from the Microsoft team. And in this environment, your students can use JavaScript, Python, or blocks to program their microbit. And you have a full simulator here. So just to show you how simple it is to get started, let's go into this toolbox, and we're going to make an animation. So I'll grab a big heart, and I'm going to follow that up with a little heart. And if you're brand new to seeing an environment like this, you'll notice that right away what you are writing over in this scripting area will appear on the simulator. This is why the tool has been so successful through the pandemic. Your students can have a full coding experience creating technology in this MakeCode simulator. It's a very powerful tool with full capabilities for any computer science classroom. But now we want to transfer this program to the microbit. So what I'm doing is using the USB cord, and I'm connecting it to the microbit. So let me see, I'm coming back to Hopin. It's going to look like a mirrored tunnel for a second. Sorry, I'm just changing my camera view. Okay, so what I've done is I've added the USB cord here. And now I am going to pair it to make code. If you're using a Chrome browser, you can take advantage of a special Chrome feature called Web USB. And Web USB allows you to download straight from a website to a physical device. If you're not using a Chrome browser, that's okay. You'll just click the download button and you'll manually drag the file that's downloaded to the device in your file manager. I'll show you both ways now. To pair your device, you just follow these prompts and click connect. And so now I'm going to download my program. So we're going to give it a second. It's a brand new Microbit. We're overriding the existing program. It's the first time it's seeing the internet. It's seeing a new program. Anytime you switch, for example, from MakeCode to Python, you will have a small delay, but any download thereafter will move quickly. And there we go. We have our beating heart. Okay. So that you feel extra confident today as you get started, I want to just let you know that at microbit.org, get started, you will find a user guide. This has been especially designed for absolute beginners. And you'll find a short 2-minute video on each of those features I just reviewed with you. So if you want to learn how to use the buttons in your project today, you can watch this quick video and you'll see beginner projects. Projects for getting started using the buttons in your project. And when you open up one of these, you'll see a 30-second video showing you the project, and then about another 2-minute video showing you how to code it. Now, just, depending on what your experience level is, this may be perfect for you. If you're more experienced, let this be a stepping stone for you to learn about that feature, but then integrate it in a new way into your project. So these getting started guides are really meant to help you learn a new feature and integrate it in your way into your project. And I think that's it for now. I'm coming to my time here, so let me stop sharing. And I'm going to turn the camera back. And that's it. All right. Any questions that I haven't answered? Where can you get help with Scratch? Put that link in the chat right now. Here's your Scratch link. You're welcome. I'll be just hanging out here until they kick me out, so keep your questions coming. That does conclude the Getting Started project. Thank you very much, everyone. Well, you're welcome. Oh, Gina, I'm sorry to see that. Yes, if you are if you're in the startup mode, taking your Microbit out of the box, you will want to, you actually don't need to go through the startup mode. You could just put the USB cord in right away and download your first program. So yes, let me change my camera view. We'll go over the last few steps, and I will, for Jana, and I will show the startup process again. That's easy. Okay, so let's see if I have another new Microbit. I don't have another new Microbit at hand. Just to let you know, when it says hello, the next thing it should ask you to do is press A and then press B. So you'll want to do the, yeah. Okay, so you did those 2 steps. Okay. After you do that, press A and press B. What happened next? Did we shake or did we clap? You should do, there should be the next message that scrolls across. I think it follows these steps here in this guide. So press A and B, shake, and then you're going to chase the dot. So you've got a solid dot and a blinking dot, and you want to tilt it around until those 2 dots come together. Clap 5 times, and then it's time to connect. In our case, we did USB. Yes, Joseph, there is a way to do that. Excellent. I'm glad that helps. Jaina, were you also asked a few steps from MakeCode of how to download your program? Okay, I can do that. One moment. Let me just share my screen again. So in this example, we've already written the code, and we just want to show how to download. Oh, and actually, Jaina, I'm glad you mentioned this. I forgot to show the second way if you aren't using a Chrome browser. So let me disconnect, and I'll start from the beginning for downloading. Okay, so you can pair your microbit by clicking these 3 dots, pair device. Then you select pair device again, and now you'll choose your microbit in the drop-down. Once you've done that, you can click the download button. Okay, so you may have just noticed the file was created externally. It didn't go directly to my microbit. Sometimes that happens when you pair and unpair in MakeCode in the same session. The right thing to do is close out of MakeCode completely and relaunch it. But this does give me the ability to show you what do you do with a file if you don't have that one-click download. So let me open up my Finder here, and you'll see that my microbit is now listed as one of these drives. So I can go into downloads and take the file, and I can drag it directly to the microbit. So I'm just manually putting the file on there, and you see that yellow light flashing. That shows you the file is transferring. So when this light stops flashing, the file will be on there. And there we go. Need to come back and check the chat and see if that helped. Okay, so this demo will describe how to use the alligator clips to power an LED. Okay, so as I mentioned, the key with LEDs is looking for the short leg. Oh dear, that lighting isn't very good. So the slightly shorter leg is your negative leg. And one of the tricks with electronics is you're trying to find the negative terminal on whatever the thing is in your hand. And once you find the negative terminal, you want to connect that to ground. So we'll just clip that on there. In this case, we only have one other option for something to clip to. And so this is going to be we want to control it. So we're going to connect it to pin 0, 1, or 2. If I just wanted to give power to this LED, I could complete the circuit by connecting this leg to 3V. And I'm going to do that now just as a demonstration. So, and also to check if my LED is burned out before I go through the process of programming it, I can grab another LED if it's, and I may have just burned it out. Okay. Yep, that LED was about to die. So it flashed for a second. I've got a whole bunch of LEDs here. Let me grab another one. Okay. So I've got another one here. I'm just grabbing the short leg. You actually want to use a resistor. It might be that I'm giving it too much power. Let me just check. Okay. So I've got a fancy LED here. This one is fading through RGB. As soon as it gets power, it has a little program that it runs. So this has not been programmed. It's only getting power from power and ground here on the microbit. But as I mentioned, we can control the LED with one of our pins. So I'm going to now program, whoops, that was dangerous. I'm now going to connect the short leg to ground and the long leg to pin 0. So let's write a program now and control pin 0. Okay. So in my scripting area, I'm going to start with, let's just use buttons. We can make our LED go on and off. We'll do button A to turn it on. And I can use button B to turn it off. Okay, now the Microbit doesn't know that an LED is attached. All it knows is there's some sort of electronic component that's connected to pin 0. And actually, the Microbit itself doesn't even know that. It's not currently sensing anything connected whatsoever. I am going to have to program the Microbit to do something with pin 0. And so I'm going into this pin toolbox here, and you notice words like digital and analog. And what these refer to are digital options are 1 or 0, on or off. An analog option is going to give you a range to play with from 0, in this case, to 1023. Analog values are really fun when you're playing with music or other types of output where you need a range, you're trying to get some detail. Digital values are helpful when you're just using on and off values. And in this case, I just want to do on and off for my demonstration. So we'll use this block, digital write pin. The difference between reading a pin and writing a pin is whether you're sending information or receiving information. And in this case, we want to write the pin because we're sending information, we're telling it to turn on. We would read the pin if it were a sensor and we wanted to read the data that it was collecting. In this case, we're writing. We'll duplicate that. So write pin 0. If I had plugged that LED into one of the other pins, I would choose it here. We'll do one to be on, and we'll do the other to be off. So let's go ahead now and download this program. Oh, did that? I think it went straight to my Microbit. So I've pressed the A button, and you can see that the Microbit came on. Let's see what happens when I press B. Do you see the LED went off? Let me check my, you can double click on my video to make the Microbit window the biggest. So let me demonstrate again. Pressing A writes the pin on. Pressing B writes the pin off. And now let me check the chat and see if that was helpful. Did that help, June? Thanks, Vicky. That's a great link. Perfect. I'm glad that was so helpful. And I'll do one other thing. I can share that code with everyone. I'll click share. And when you select publish, it's not going to some repository where anyone can find it. It's just generating a unique URL. And so I'm going to copy this URL and put it in the chat. And now anyone can open up that code and make a copy of it themselves. Okay, I think we're coming to the end of the time where I probably do need to leave this room because someone else will be presenting soon. Any other questions?